Okay, today we are going to start with Chapter 7, and we are going to start looking at angles in polygons. And just remember, a polygon means a many-sided figure. So we're going to kind of start with defining what a polygon is. Poly means many. So what is a polygon? Well, a polygon, in its basic meaning here, is it has to have at least 3 straight sides. And the sides all have to be straight. No curves, no circles, nothing like that. And it must be closed. As in, I always say, don't let the cows out. So like an open polygon would be something like this, where this is open on this side and the cows are getting out. Closing it would be actually closing that gate. So that would be a closed polygon. So that's just a little bit of defining there. And then the second thing is concave and convex. So on the left over here, we have examples of convex polygons. Convex polygons are basically the polygons that you see most of the time. They're just your regular triangles, quadrilaterals, pentagons, things like that. If you notice, all of the sides are closed. There's more than 3 sides on all of them. None of the sides do what we say cave in or anything like that. All of the sides are still on the outside of the polygon. Nothing caves onto the inside. Whereas if you look over here at concave, remember concave is like caving in, okay? So like this side right here on this polygon is caved in. This one has lots of places that are caved in. And this has this side here that's caved in. So when one of the sides is caved in, it looks like somebody maybe punched a side of it or something like that. That would be a concave polygon. Okay, and then the second thing is how we classify or name polygons. Those are the names we give them: triangle, pentagon, hexagon, things like that. And these right here, the number of sides, are the ones that you need to know and remember. The ones that you hear all the time, pretty much. The very common ones. So if we are going to name or classify, so if you ever see the word classify or naming the polygon, this is what we mean. So 3 sides, obviously. We've spent a lot of time in first semester with 3-sided figures, triangles. Now, under triangles, we've talked about a lot of different types of triangles. We've classified them. The very overarching name would just be a triangle. 4-sided is not a square or a rectangle. A 4-sided, the basic name is quadrilateral. And then again, we can classify quadrilaterals a lot of ways. Squares, rectangles, rhombuses, things like that. And then after those 2, everything else follows a pattern. So 5, a prefix that says 5 would be penta. So we would call it a pentagon. 6-sided, the prefix in this case would be hex. So we would be a hexagon. 7 has 2 different names. I will accept either one of them as correct. If you want to follow the pattern of starting with an H, we have a heptagon. Or the other name for it is a septagon. 8 is one that you probably have heard the prefix, like an octopus has 8 legs or arms or whatever. 8-sided figure is an octagon. 9 just looks like it's almost spelling out the word 9. It's not a nineagon, it's a non-agon. Okay. 10, if you remember some prefixes, maybe from science with deca, deci, things like that, or a decade has 10 years in it. 10-sided figures is a decagon. Okay, and then 12, we skip 11 because that's a very uncommon one that you would ever have to know the name of. And then 12-sided would be dodecagon. Okay, so these are the ones that you need to know. So if it asks to classify or name, those are the ones you need to remember. Okay, and then anything, this little note here, anything beyond 12 sides, I do not require you to remember the name of them. We just name it by its number of sides. So a 37agon has 37 sides. If it was a 26 gon, it would have 26 sides. So anything beyond that, we don't make you memorize the actual fancy pants names. So here we have, let's classify it, and then we're also going to state whether it's convex or concave. Okay, so all we really need to do is let's count how many sides it has. 1, 2, 3, 4, 5, 6 sides. 6 sides is a hexagon. And it doesn't have any sides that looks like they're punched in or anything like any corners that are on the inside of the polygon, anything like that. So we would call this convex. Okay. This next one has 1, 2, 3, 4, 5, 6, 7 sides. 7 sides, depending on what you want to call it. I'm going to call it a heptagon. And if you notice right here on this part, looks like somebody has punched in the sides of that heptagon, and that would be concave. Okay, the next one, let's count those sides. 1, 2, 3, 4, 5, 6, 7, 8. It has 8 sides, which would be an octagon. And this side right here is caved in on the inside of the polygon. So this would be concave as well. And then this last one, 1, 2, 3, 4, 5, 6 sides. So we're back over here at a hexagon. That's classifying it. And this side is caved in, so it would be concave. Okay, so just a little bit of vocabulary and things that we're going to start out our chapter with. Let's keep moving. So now we're going to look at actual angles inside the polygons. Remember, interior means inside the polygon. Okay, we'll get to exterior tomorrow, but we are looking at the angles on the inside. And we just want to know how much those angles all add up to. And every polygon, based on how many sides it has, will add up to a different number. Okay, so we already know, we've kind of figured this out in first semester, that triangles, we did that a lot with triangles, they always, 100% of the time, add up to 180 degrees. We could set them equal to 180. If it has 4 sides, then it would be 360. So a square, a rectangle, a rhombus, a diamond, any of those things, those would all add up to 360. But how do we figure out if it has just any number of sides? 5 sides, 6 sides, 37 sides, 29 sides, however many it be. There's a formula for that. So this is the formula that you need to know. And we're going to use the letter N to represent the number of sides, or how many sides the polygon actually has. Okay, so the sum, if we added up all of the interior angles, so like down here on this picture, if we added D plus C plus B plus A plus F plus E, if we added them all together, we would be able to figure out how much they add up to. And to figure that out, we take 180 and we multiply it by the number of sides minus 2. Okay, that minus 2 is always the same. It doesn't matter how many sides it has. We always subtract 2 from the number of sides. Okay, so in this case, again, we're going to do a little counting. We have 1, 2, 3, 4, 5, 6 sides. So using our formula up here, we would have 180 times 6 minus 2. And 180, which is basically 180 times 4, right? 6 minus 2 is 4, would be 720 degrees. So if we added up all these guys right here, all 6 of the angles, they would add up to 720, and it doesn't matter the shape of the hexagon, they will always add up to 720. Okay, so let's look at just one more here. How many sides? N. 1, 2, 3, 4, 5. There's 5 sides. Let's remember that's called a pentagon. Okay, back here on the previous one, I should have mentioned this. This is a hexagon. Okay, and the sum of our pentagon back over here is 180, and is 5. We always subtract 2, and 180 times 5 minus 2 is 540 degrees, which means if we added this angle plus this angle plus this angle plus this angle plus this angle, all of them together would equal 540 degrees. Okay? Now we're just going to add a little bit of algebra into it. You know, geometry is not complete if we don't put a little bit of algebra into it. So we are just going to do it's going to be a multi-step type of problem. Okay, it's not going to be something we do in one step, and I kind of have stepped these 3 steps out for us. Okay, so if we look at our polygon that we have here for question number 7, okay, we have 1, 2, 3, 4 sides. Okay, 4 sides. That's a quadrilateral, just if we were going to classify it, which you'll be asked to do several times, so that's why I'm making sure I mention those things. We've talked a lot about, quite a bit about quadrilaterals and stuff. They add up to 360, but just in case we forget, we get that because it's 180 times n, which is 4, minus 2, which is 360 degrees. Now this 360 is key because when we add all of our angles up, that's what it's going to add to be. So we're going to have x plus all of our angles, 45 plus 65 plus 95, and it is going to equal 360. So this number right here, oops, daisies, I didn't mean to erase that, 360. This number here is going to be different based on how many sides it has. It's not like last semester where I'd be like, oh, it's a triangle, 180. Now we're going to have some quadrilaterals and pentagons and hexagons. So we're going to have to remember it's not always the same number on the right side of the equation. So when we go ahead and combine our like terms, these guys are our like terms, okay? And we would get x, when we add that 45 plus 65 plus 95, we should get 205 equals 360. If we subtract 205 from both sides, we get that x is 155 degrees. Okay? And if you look, the pictures in this unit should be drawn pretty much to scale. So if you look at this x right here, that's an obtuse angle. It's bigger than 90 degrees. It's less than 180. So 155 would be an answer that makes sense. Okay? So let's take a look over here at the next one. Okay? First of all, we have to figure out how many sides. That's n. We got 1. This little guy here is 2, 3, 4, 5, 6, which would be 6 sides. Again, our formula tells us that we take 180. 6 minus 2 is going to be 720. So when we add all of our angles up together, it's going to equal 720 because it is a hexagon. Again, hexagon, classifying it again, just getting those vocabulary words going through our head as many times as we can. So we are going to add all of our angles up, and don't forget this angle right here is 90 degrees just because there's not a number there. There's that little square corner. The little square corner always says 90 degrees. So we're going to add x plus 140 plus 130 plus 120 plus 90, don't forget that one, plus 150, and since it is a hexagon, it is going to equal 720. We're going to combine all of our like terms. We get x plus 630 equals 720. Subtract 630 from both sides, and we get that x equals 90 degrees. And if you look up here at x, this angle right here, okay, it's not labeled with a square corner, but we just calculated that it is 90 degrees. And if you look at it, it kind of looks like a 90 degrees. We can assume that just by looking at it, but we can't just assume anything. We always want to make sure that if it has a 90 degrees, it's always labeled there also. So I want you to, when you are done listening and taking notes on this video, I want you to submit these notes to Schoology, to Angles and Polygons, completed notes, and then the second thing I want you to do is I want you to complete the first slides 1 through 7 of Angles and Polygons class kick. Okay, good luck.